let's talk about the sum and difference identities for cosine. So cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. And then similarly for cosine of a difference of angles, it's the same but the sign has changed. So cosine of alpha minus beta is equal to cosine of alpha times cosine of beta plus sine of alpha sine of beta. Now the reason that this is a useful identity is it allows us to compute exact values of cosine for angles other than the standard angles that we know from the unit circle. So as an example of what we can compute, let's compute cosine of 75 degrees. Now 75 degrees, you might notice, is equal to 45 degrees plus 30 degrees. And because we can express 75 as a sum of two angles, which we know the values of cosine and sine for 45 and for 30 degrees, we'll be able to compute the cosine of 75 degrees very easily. So let's apply our formula. So again, it's cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. And now again, we know each of these values, so we can compute them. We know that cosine of 45 degrees is the square root of 2 over 2. We know cosine of 30 degrees is the square root of 3 over 2. And then we know sine of 45 degrees is the square root of 2 over 2. And sine of 30 degrees is a half. And now we can just simplify this a little bit more. We get the square root of 6 minus the square root of 2 all over 4. So that's our answer. That is cosine of 75 degrees. Alright, let's look at one more example. Now we want to compute the cosine of 15 degrees. Well, 15 degrees, you might notice, is the difference of 45 and 30. So cosine of 15 degrees is just cosine of 45 degrees minus 30 degrees. And just like before, we know how to compute sine and cosine of 45 and sine and cosine of 30, so we'll be able to compute the cosine of 15 degrees using our difference formula. Okay, so now it's just like before, except it's a plus sign instead of a minus sign. So cosine of 45 degrees times cosine of 30 degrees. And now it's plus sine of 45 degrees times sine of 30 degrees. And again, we know how to compute all these values. So as before, we get square root of 2 over 2, square root of 3 over 2 for the cosine of 30, and then we'll add square root of 2 over 2 for sine of 45 times a half for sine of 30 degrees. And simplifying, we get square root of 6 plus the square root of 2 all over 4. So that is our value for cosine of 15 degrees.